Hello, good day, viewers. You're welcome to Chemistry Hangout. Okay, for people sitting for Neco, you're writing Neco. I want to believe you have seen the titration video. If you have not seen it, please go and watch it. There are a lot of things for you there. Okay, there are a lot of things you need to digest before the exam. Now, coming to this qualitative analysis. Coming to this qualitative analysis. I love this qualitative analysis because I will explain something and it will even give me, it will give me room to do some other further videos for us to understand. But let me quickly start with the qualitative analysis for Neco 2023. So if you are doing Neco and you are on this channel, then you are in the right place. So take your seat and pay maximum attention so that I can take you through a wonderful journey into the qualitative analysis for 2023. I love that analysis. Okay, if you are just watching this YouTube channel for the first time, kindly subscribe to this channel. This is one of the best channels as far as chemistry content is concerned. So what do we have for us for today? These are my predicted questions for Neco 2023 chemistry practical. So C is an inorganic salt. Carry out the following exercises on C. Record your observation and identify any gas involved. State the conclusion you draw from the result of each test. Put part of C in a test tube and add about 10 centimeter cube of distilled water. Test the solution with litmus paper and divide. Okay, let's delve into the practical. Please get me my matches and I will give you my matches because take the remaining sample and eat it. So let me take my matches. Okay, so let me take you through the journey of 2023 Neco chemistry practical qualitative analysis. Okay, let's go. Okay, so the first one, they said put part of C. This is C. This is the sample. This is the sample. C is the sample. Okay, this is the sample. This is my water. This is water. So I'll put water. So let's observe. I've told you that when you are doing qualitative analysis and you are putting water in a sample, what you are testing for is the solubility of water. Okay, so look at that, very soluble, very soluble. Can you see it? Very, very soluble. Okay, so let's go now. Let's go. Test, observation. Let me put observation here. Observation and the inference. Okay, so let's have a test, the observation, and the inference. So please number it accordingly. I've always said that. So the A now. So sample C is because they said C. So sample C plus distilled water or 10 centimeter cube of distilled water. Sample C plus 10. Let me put the 10 according to the instruction. Let's follow the instruction. Plus 10 centimeter cube of distilled water, but I actually use my discretion. Okay, I actually use my discretion to add the water. Okay, sample C plus 10 centimeter cube of distilled water. So dissolves. That means it dissolves completely. The sample dissolves completely in water. As I've seen here, you can see dissolves completely in water. So it means C is a soluble salt. This is clear? Okay, so they said add 10 distilled water, test the solution with litmus paper. So plus litmus paper. So I'm testing with, definitely if it has effect on blue, it will not have effect on red. If it has effect on red, it will not have effect on blue. So that's just it. Let's see, let me use. So I'm using my red. Let's see. Come closer, come closer. You can see that. Can you see it? Changing the red to what? To blue. Okay? So say tones or change tones red litmus paper blue. Okay? Then we can now infer that solution C is alkaline. That's the reason why it's turning red litmus paper blue. If it turns blue litmus paper red, then it is what? It is acidic. I think this is clear. Okay, let's move on. Divide the solution, that's the solution, into two portions. So this solution, we are dividing into 2 portions. Okay. 1, 2. But I will divide into 3 because I still want to show you something. I love this practical, it's very interesting. So let me just have 1 as a reserve, or even 2 as a reserve. Okay. So, but we are just using 2 portions. So you divide to 2 portions. So from there, they said divide the solution into 2 portions. To the first portion, add barium chloride. So can you see, using this as first portion, add barium chloride. Add barium chloride. So this is the first portion. Let's check. This is my barium chloride. Okay, let's see what's going to happen. Wow, look at that. This is a white precipitate. You can see that. You can see this is a white precipitate formed. A white precipitate formed when I added barium chloride. So please don't forget to number accordingly. So first portion plus what? Barium chloride. So what is the observation? You can see it. Can you see that? Okay. So white precipitate. White precipitate formed. So if white precipitate is formed, you are using barium chloride, and white precipitate is formed, you have CO3 2 minus, okay, SO4 2 minus, and what? SO3 2 minus. Present. These are the radicals that could be present if this is formed. But they said something there. They said followed by dilute HCl in drop and in excess. Okay, dilute HCl in drop and in excess. Let's see. In drop, then in excess. Let's see. Wow. Wow. You can see the dilute HCl is dissolving the white precipitate. Let me shake so I will see. Wow. You can see that. Can you see that? Can you see? You can see the white precipitate is dissolving. Okay, let me show you again. Yeah, so that you see it very well. Let me add barium chloride so that you see it very well. Let me just use little. Okay, so that you can see this. I want you to see the reactions well. You can see that's the barium chloride now. You can see. Then I had dilute HCl. I want you to see the reactions clearly. Sorry. Can you see that now? You can see dissolving the white precipitate. Let's wait for some time. Very important. Let me shake so that you see it. Can you see? Can you see that? What do you notice? The dilute HCl now is now dissolving the white precipitate. You can see it's now colorless. So it's now colorless. Let me shake this too so that you can see it. Let me shake it so that you can see it. You can see dissolving the white precipitate. Can you see that now? So very important. Can you see it? I had to do this so that you see it. Can you see it? Because this one, I had to just add little of this one so that the dilute HCl in excess will be obvious. You get that? Can you see dissolving into colorless solution? You can see that colorless solution. So we can say white precipitate form plus dilute HCl aqueous in what? In excess. Very important. Dissolves, right? Dissolves the what? The white precipitate to form, you can see colorless, to form a colorless solution. So what are the inferences? You can have CO3 2 minus, okay, or SO. So it dissolves the white precipitate to form SO3 2 minus. Present. You know, the reason why it is like this is because you can see I have 3 ions here before, but because of this reaction, because of it dissolving this, you can see, because if it doesn't dissolve, it means it is SO42 minus that is present. If the white precipitate doesn't dissolve, then I can confirm that it is SO42 minus that is present. But because it is not SO42 minus that is present, that's why you see the dilute HCl dissolving the white precipitate. So when it dissolves the white precipitate, then I'm now, I'm suggesting that either of these two, because either of these two is present because of its diluting. So if you want to get this very particular one very well, you have to use just little of the sample so that the excess HCl will be obvious, because if it is not in excess, it will not dissolve. Do you understand? And the more this sample, you can see this one is small, it will still give me a result. The more this sample, it means the more the concentration, and the more the dilute HCl that will now dissolve it to give a colorless. So if you really want to get it, you have to use little of the sample, then you dissolve in excess HCl to give something like this. Okay, so that is that. So the first portion, we have done this, followed by dilute HCl in drop and in what? And in excess. Okay, very important. Then to the second portion, add dilute HNO3, then pass the gas into lime water. So let's quickly get that done. To the second portion. Okay, so this is the second portion. Okay, but let me have my lime water here first, because I think I did this in WAEC practical, the alternative B. If you have not checked the video, I did this same test that I want to do. So if you have not checked, you can check it tomorrow. But let's do it again for people that know watched that video. So let's do this again. So this is my lime water now. Okay, this is my second sample. So they said add dilute HNO3. So this is my dilute HNO3. Okay, so this is my dilute HNO3. So let me first of all add this. Okay, wow, you can see I'll add effervescence. Let me quickly pass the gas into this very quickly. Let's see what will happen. You can see that. Can you see now? Can you see? You can see this. You can see this is my lime water. You can see colorless, but when I pass the gas that is evolved from this very particular one to this, you can see how milky it is. So let's have our test, observation, and inference now. So to the second portion, let's have it here. Let's have it here so that it will be. So observation, and inference. Okay. So don't forget, I've told you the numbering is very important. What is the numbering here? That is A Roman figure 2. So we have 1 here, so we have 2. Okay, so second portion plus dilute HNO3 aqueous. So what happened? The observation number 1, there was effervescence. There was effervescence. Okay, so a gas, colorless and odorless, evolved. Okay, can you see that now? Effervescence, a gas, colorless and odorless was evolved, turning. But let me first of all have it with litmus paper. You can put that too. Then we can turn, because that gas, since it's CO2 gas, we have confirmed that, turn blue, turn blue litmus paper red. Okay, so from here we can say the gas is acidic from this place. Okay, then the confirmatory test that we did, that it turns lime water milky. I see that. Then we can now say CO2 gas confirmed from CO3 minus or HCO3 minus. Can you see that? So very, very important. The second portion plus dilute HNO3, effervescence, a gas, colorless and odorless gas level, turn blue litmus paper red. Why didn't I test it with blue litmus paper? Because of course, if I want to pass it into this, I should have a delivery tool. Because if I leave it, if I'm testing with litmus paper, before you know, all the gas would have evolved. So if I put it in lime water, it will not give me this confirmatory test. Do you get that? So that's the reason why I did not actually test with blue litmus paper, because all the gas would have evolved. But if you test with blue litmus paper, it should give, it should give this, because the gas is CO2 and CO2 gas is acidic. So it will turn blue litmus paper, and that's why I said the gas is acidic. Okay, so from here, turns lime water milky, you can see that the CO2 gas confirmed from CO3 to -4, AC3 -4. Okay. Now let me quickly say something here. You can see the second portion plus dilute HNO3. It could be H2SO4, it could be HCl, it will still give the same test. Because HNO3 is an acid, HCl is an acid, our H2SO4 is an acid. So when they react with any triazocarbonate, CO2 will still be liberated. So don't get yourself confused. If it is dilute HNO3, it will still give the same result. If it is H2SO4 dilute, it will still give the same result. If it is our HCl, it will still give the same result. So irrespective of the acid they are using, it will still liberate this very particular CO2 from your triazocarbonate. I hope that is clear. So very clear. So take the remaining sample. Then that's B now. The remaining sample. Take the remaining sample. Then plus what? And eat it. Now I will do a series of this, but I think I will just take time to, I won't take much of our time here, but I'll just do a series on this, because this is more or less what we call a flame test. Yes, although your flame test cannot be used to confirm a particular metal ion, but we can use it to test for it, maybe it is there. Because how your flame test work is that it works with thermal energy. When those electrons, okay, when they acquire energy, they jump to what we call an excited state. So when they are now, releasing back the energy that they got, they will now begin to release it in form of photons. So I think I will do a teaching on that, but this is just a flame test. So let me put this, let me come with this. Then very quickly, now the question can come like this, it will still give the same thing, because when you subject a particular compound to flame test, we determine what the color, well, we determine the metal ion by the color. I'll still do some series about that. So because all these metal ion, they have their color in the spectrum, the spectrum line. So they have their color. So but for this, let's see the color is going to give us. Let's see the color is going to give us. But I still want to, let me do this. Let me still do this. Okay, this is part of the portion I dissolved, I dissolved. So I will use the liquid. I've dissolved this very particular salt in water and the dry salt. So I will use the two for you to see that we are still going to get the same result. And flame test is another interesting aspect of qualitative analysis. So let's see. So let me light up this. So it's another interesting aspect. Okay, let me lower it. Because I need that blue flame. Okay, good. Okay, now look at this. Take part of the salt. Can you see? This is the salt now. Look at it. Look at something. You can see the golden yellow flame. Can you see? Can you see the golden yellow flame? Can you see that? You can see the golden yellow flame, telling us that, when we say golden yellow like this in flame test, we know that is sodium ion. You can see the golden yellow. Can you see it? Can you see the golden yellow here? You can see it. If I put it here, can you see? Can you see the golden flame? You can see the golden yellow flame. So from there I can say remaining test plus heat. Then I will have, let me use this too. Let me dip, even if it is a glass rod. Look at it, I'm dipping a glass rod in. Maybe they do not tell you to add the remaining sample. Maybe they ask you to use the liquid that you have dissolved this sodium carbonate in. Let's see. If I dip my glass rod here, look at it. Can you see that? Can you see it's still the same, still giving us the same test. Can you see that now? So irrespective of the one they ask you to do, it's still going to give you the same result. If they ask you to dissolve this in liquid, put your glass rod and subject it to it, it will still give the same result. So remaining sample plus heat, we have what? A golden yellow flame observed. And if it is a golden yellow flame, then we said sodium is is what is present. You can see, and that's it. That's it. I hope this is clear. So for other, maybe I'll do a series on the flame test so that we understand, but for the sake of Neco, this is all what they might not ask you this. They might not ask you sodium ion, but we are doing this so that if they ask you, you will not be, you will not be gotten unaware. That's why we are doing this. So for this, if they ask you to subject it to indefinitely to give you a sodium and sodium ion present. And that is that for Neco. So if you are doing Neco, this is all what you need for your qualitative analysis, and I bet you around 80% of this thing you are going to get that. You should trust me for that. So if you are just watching this YouTube channel for the very first time, do well to subscribe to this channel. We love you. For people that are subscribers, we love you. Thank you so much. We appreciate your prayers, we appreciate your calls. And for teachers that have reached out to me about how to prepare laboratory reagents, the video training we did, some have gotten it. If you have not gotten it, this is another time to prepare. You are going to summer holiday, you need to prepare well for the next session that is coming. You will need those videos. For you to actually be able to do all those things, you will need those videos. And not that you are going to join our community where we actually interact as far as chemistry is concerned, just to make us better as teachers, and that's what we do. So we love you. If you have not gotten the training, do well to get the training. So for Neco students, I wish you good luck. Even if you have done WAEC, you can watch this video, it will help you. If you are a college student, you are studying chemistry, you are in 100 level, all these things are what you will do, so they will help you. So I think maybe later, my subsequent video, I will do a teaching on flame test alone, where I will be coming to do flame tests of different, compound, trying to test for the metal ions in those compounds. So these are all what we need for the Neco practical. I wish you success. I wish you the best. Prepare well. Go over this over and over and over again, and I bet you will not find it difficult on the day of the exam. I love you. Till we'll be back here. Stay chemically active. Thank you.